morning class. For today's geography, we'll learn about latitudes, longitudes, sea breeze, and land breeze. So let's start with what are latitudes. So first thing which gets asked in CDS and ND is, are latitudes and longitudes both equidistant, or thus they are not equidistant. So latitudes are always parallel, whereas longitudes they start at the pole and ends at the pole, and they are closer to each other near the poles, and then they broaden up near the equator. So longitudes are not equidistant. So let's go for latitudes. So from latitude, this is an important point. So latitude is the measure of how far north or south a point is from the Earth's center. Then we have, due to the Earth's slight flattening at the poles, the distance covered by 1 degree of latitude varies. At the equator, 1 degree of latitude approximately 68.7 miles. At 45-degree latitude, 1 degree of latitude equals around 69 miles. At the pole, 1 degree latitude covers about 69.4 miles. On average, 1 degree latitude is considered to be approximate 69 miles, that is 101 kilometers. So from here, this is important. What is latitude and what is its total extension? So that is 111 kilometers or 69 miles. Now we go on to important parallels of latitude. So firstly, North Pole is at 90 degree, South Pole is at 90 degree south, right? Tropic of Cancer at 22.5 north, Tropic of Capricorn 22.5 south, Arctic will be at 66.5 north, and Antarctic Circle will be at 66.5 degree south. So firstly we have North Pole at 90, South Pole at 90, Tropic of Cancer 23.5 north, Tropic of Capricorn 23.5 south, Arctic Circle at 66.5 degree north, and lastly we have Antarctic Circle which is at 66.5 degree south. Then we go on to latitudes. So the largest latitude is the equator. Tropics always have heat surplus, and temperate and polar regions are heat deficit, right? So largest latitude, this is your equator. Tropics always will have heat surplus, right? This is your tropics, heat surplus. Temperate and polar regions will have heat deficit. So this is your tropics. This is your temperate and polar. So this is your heat deficit, right? Then we go on to latitudinal heat zone of the earth. So we can see the tropics, sun he strikes most directly. So tropics will always have heat surplus. Here there is an angle due to which there is heat deficit. Right? Then we go to latitudinal heat zones of the earth. The region between the Tropic of Cancer and Tropic of Capricorn gets the most heat from the sun. This is known as torrid zone. Between Tropic of Cancer and Tropic of Capricorn, the sun never shines directly overhead. This is known as temperate zone. Then we have the areas close to the poles between the Arctic Circle and the North Pole, and between the Antarctic Circle and the South Pole. It's very cold, and this is called as your frigid zones. So we have torrid zone, temperate zone, and lastly we have frigid zone. Torrid is your most hot. Then we have temperate with moderate temperature. and we have frigid zone where it's freezing temperatures. Now we come on to longitude. Longitude is a measure of distance in degree east-west of prime meridian. On a globe, longitude lines are shown as semicircles that go from North Pole to the South Pole, passing through the equator. The prime meridian at 0 longitude runs through the Royal Astronomical Observatory at Greenwich. All other meridians or lines of longitude spread out from the prime meridian. Meridians get close together near the poles, just like lines of latitude get shorter. One important job of longitude line is to help figure out local time compared to Greenwich Mean Time, also known as world time. The international date line is directly opposite to the prime meridian at a longitude of 180 degrees. So these are very important points of longitude. So firstly, we have to know this one. This is very important. International date line is at 180 degree opposite to GMT. Longitude help figure out GMT. Meridians get close together near the poles, and all other meridians or lines of longitude spread out from the prime meridian, going both east and west up to 180 degree. So these are few of the important points of longitude. You can write down these points. So as we can see in this diagram, so these are the longitudes. They are closer at the poles and then they get broader, right? So 0 degree is your Greenwich in London, 180 degree is your international date line. So these are important points here. Next we have like longitude and time. So each 15 degree of longitude is equal to 1 hour. So suppose we are at London, right? It's 0 degree, and then the question asks you move 30 degrees east. What, how many hours have passed? So it will easily be 2 hours because it's east. On the east we gain time, when west we lose time. So this is something you have to remember. In east we gain time, on west we lose time. So earth completes a full rotation of 360 degree in 24 hours. So it moves through 15 degree of longitude every hour, or 1 degree every 4 minutes. Earth spins from west to east, so moving 15 degree eastward adds 1 hour, while moving 15 degree westward subtracts 1 hour. Places to the east of Greenwich see the sun earlier and gain time, while places to the west see the sun later and lose time. To find local time from Greenwich Mean Time, we add or subtract the hour difference based on given longitude. The graticule is a network of latitude and longitude lines on a globe. Great circles are imaginary lines that divide the Earth into two equal halves and have the center at the Earth's center. So here one you have to remember is firstly, Earth's full rotation 360 degree in 24 hours. So it moves 15 degree every hour, or 1 degree every 4 minutes. So it is important. Then this one. While moving east, add 1 hour. While moving west, subtract 1 hour. So this is very important here. East will always add, west will always be subtracted. So write down these important points from here. So this is your Earth rotates 360 degrees in 24 hours. 360 by 24 equals 15. So every 15 degree longitude is equal to 1 hour. Now we come on to international dateline. So when traveling east from Greenwich, a person gains time until they reach 180 degree meridian, where they'll be 12 hours ahead of GMT. Traveling west from Greenwich, a person loses 12 hours when they reach the 180 degree meridian. So there's a total of difference of 24 hours or 1 day across this meridian. The international dateline located at 180 degree meridian, crossing it changes the date by 1 day. Traveling east across the day, person gains a day, while traveling west across, person loses a day. In the Pacific Ocean, the international dateline curves away from the straight 180-degree meridian near places like Bering Strait, Fiji, and Tonga. This prevents confusion in islands where the meridian passes through, ensuring consistency in the day and date. So what it's saying here, so once we move west, we lose 24 hours, but we gain time. And once we move east, we gain 24 hours, but we lose time. This is because an example, easy example remember is, suppose it's 15th in Korea, we move to USA. In USA, it will be 14th. So from west to east, we lost 24 hours, but we gained the day, right? Similarly, if from US to Korea, we gained 24 hours, but we lost a day. So this is the easiest way to remember it. So these are the points from latitude, longitude, Greenwich Mean Time, and international dateline. In our next class, we'll be learning about sea breeze, land breeze, rocks, and classification. Thank you, class.